Hey guys, this is the second video in our series on electrochemistry. I've already introduced how to read this chart. Let's go over a couple more things about it. Number one, if you are considering how strong of a reducing agent these substances are, a reducing agent is something that causes reduction in something else. Conversely, an oxidizing agent is something that causes oxidation. Causes reduction. So the other way to think about this is if you are an oxidizing agent, you cause oxidation. You cause somebody else to lose electrons, which means you yourself are reduced. So good oxidizing agents are actually reduced very easily. On the flip side, if you are a reducing agent, then you cause reduction in somebody else. Reduction is the gain of electrons. So therefore, if you're causing somebody else to gain electrons, you yourself, the reducing agent, is oxidized. Oxidation and reduction. When we're looking at our list, something is spontaneous when the overall voltage for the reaction is positive. The voltage potential is shown as E in these tables, and the units are volts. Because these are considered for 1 molar solutions and 25 degrees Celsius, often these values are shown with a superscript E, meaning 1 molar concentration of the things that are aqueous, for example, these ions, and 25 degrees Celsius temperature. That's what the superscript E means. All of these values are actually relative to the element hydrogen. If you notice, the hydrogen has a value of 0 on this chart. So everything else is relative to that element. So as we go down the chart, they become better at gaining electrons. The voltage is positive, and fluorine is a good gainer of electrons, showing a positive voltage all the way down at the bottom of 0.287. So if we pair fluorine gaining electrons with something above it, the fluorine will take electrons from anything on the opposite side. The fluorine will oxidize anything above it on this side. Let's take an example. I'm going to create a battery, and I need to list the battery in terms of 2 different kinds of reactions. I'm going to list it in terms of oxidation and reduction. For example, I can pick any number of situations. I'm going to pick something made of lead, and I'm going to choose lead to be in the aqueous ion form, and I'm going to choose calcium in the solid form. And the reason why I've chosen them this way is because I need to pair somebody losing electrons with somebody gaining electrons. Notice that because the lead is aqueous and positively charged, the lead is going from an aqueous positive state to a neutral elemental state. That said, I look up on the chart above and I try and find lead 2 positive. I notice that, 2 electrons are added to the lead to give me lead neutral. And the electron volts for this reaction is, the reduction potential is negative 0.13 volts. The calcium is going from neutral, solid calcium, to calcium 2 positive. This means that the calcium has lost 2 electrons. Notice that 2 electrons have been gained and 2 electrons have been lost. When I look at the reduction potential above, I see calcium here. Notice that in this direction it's shown as negative 2.87. I need to reverse this sign because I'm actually writing this equation in the opposite direction. So when I reverse the equation, I change the sign to positive 2.87 volts. I must make sure that the number of electrons lost equals the number of electrons gained. And when I do that, I can then add up these two numbers. In essence, though, I'm actually subtracting 0.13 from 2.87, and that's because this is positive and this is negative. I sum these two values. And when I do that, I get a value of 2.74 volts. And it's positive 2.74 volts. And because my answer comes out positive, that means that this could be used to create a battery. That the pull of electrons off the calcium and onto the lead ion is a spontaneous process. Just to review what we did, to determine if I can make a battery out of any given set of substances, I want to create the overall reaction that I'm interested in looking at, and then break it down into an oxidation and a reduction. Oxidation is lost, reduction is gained. I use the numbers in the table above, and then I simply add them together to get my overall voltage for the battery.